Hey guys, welcome to Coach Scott's Chemistry homework tutorial. We're going to start this web page. Going to help you guys out with this Gay-Lussac's law worksheet. So again, the first thing you want to do when you do these, and this is where people have a difficulty with any of these gas laws, is identifying what you're dealing with, right? So this is what I want you guys to do. First, read the question. All right, so it tells us here, determine the pressure change. All right, so we're changing our pressure when a constant volume, so volume is really not involved with what we're doing, of gas at 1 atmosphere is heated from 20 degrees C to 30 degrees C. That tells me something right there. First, I'm going to have to convert the Celsius into a Kelvin temperature. And how we do that is we add 273 degrees to the Celsius, then I'll give us Kelvin. And this is what we did right here with the 20 degrees C on the initial side. All right, and then our temperature change, or our final temperature, was 30 degrees C. I've got to convert that over to Kelvin, and how I do that is to add 273 degrees to the Celsius temperature, and that'll give me 303 degrees K. All right, so now we're going to break this down because volume is constant. We're not going to worry about that. So I'm going to identify my initial pressure, which was 1 atmosphere, my initial temperature, which I converted from Celsius into Kelvin to 293 degrees. So I move that over there. Don't know the second pressure. That's our unknown. Okay, so we're just going to put a question mark there for right now. My second temperature, I moved from over there because I converted that 30 degrees C into Kelvin. So now I can do something. So what we're going to do is use Gay-Lussac's law, which states that pressure is in a direct relationship with temperature. So as pressure increases, temperature increases. So I set up my formula, P1 over T1 equal P2 over T2. I start adding things in. I put my or subbing things in. I take my first atmosphere, right, or my first pressure, and put it right here where P1 is. I take my initial temperature, put it below in the denominator, the temperature 293 K. I don't know what my P2 is, so that's like the unknown, or the X. And then I put my final temperature here in the denominator, 303 K. So now we do something that you guys learned in algebra, pre-algebra, cross multiplication. So I'm going to multiply this denominator by that numerator, and I end up with 1.0 atmospheres times 303 Kelvin. All right, and then I take this denominator, multiply by the unknown in the numerator. So I get 293 K times the final pressure, P2. So I end up with 1 atmosphere times 303 Kelvin equals 293 Kelvin times the unknown, P2. I need to get the unknown by itself, so I'm going to divide both sides by 293 K. All right, and I can cross that one out. Divide this side by 293 because algebraic rule, whatever I do to one side, I've got to do to the other. So I can cross that unit out, dimensional analysis, and if I multiply 303 times 1 atmosphere, I get 303. And then I divide 293 into 303. All right, get that. And I end up with 1.03 atmospheres. So that's the unknown, or what we solve for. And let's always see if it makes sense. I'm going to look at my popsicle stick. And my initial pressure, or my initial temperature, was 293. It raised, right? Temperature went up. Okay. So therefore, pressure has to increase also. And if I look here, my pressure started at 1 atmosphere and ended up at 1.03 atmosphere. So indeed, Gay-Lussac's law was correct. Pressure increased. Okay, and we'll work more of these problems as we go through. Okay, so hopefully this will be beneficial for you. And well, anyway, thanks for listening.